In this video, I will show you how the List.Generate function works in Power Query. We will start with a basic example and build more advanced examples on top of that until you get it till the very end. So if that's something you wanted to learn, stay tuned. So I'm very excited to talk about this topic because List.Generate is something that can be pretty complex. In essence, List.Generates help you in generating a list, as the name suggests. And the List.Generate function has 4 arguments, which I will walk you through right now. But with different ways, you're able to generate a more complex list with numbers, letters, objects like lists and tables within the list. Anything you like, it's quite flexible. Let's just see a few examples to see if you can follow along. So in Power Query, let's start with a blank query. And we can start by writing List.Generate. Here we go, List.Generate. And List.Generate has 4 arguments, of which the first 3 are mandatory. So let's see how that works. So the first argument is asking for an initial as a function. Now, this is just very descriptive, but what it's asking you is what does it need as initial value? So what value should the series start with? So if we try to create a series with a single value, we could do something like this. We just open a bracket and close a bracket to indicate a function. And then what we can write is a number, like the number 6. Number 6 will then be your initial value, the value to start the series with. Let's write a comma here so we can start on our next argument. Then we're going to go to our next part. And as a second argument, List.Generate wants to know if I'm going to generate a series, how long should I generate the series for? It wants to have a condition as a second argument so that it knows that while it's true, it should keep creating the series. And the first time that the condition is false, then the creation of the series should stop. So in this case, we could, for example, write each, and we write an underscore. And we could write, for example, each value has to be smaller or equal to 6. Condition to check, or as long as condition is true, create series. All right, let me just put the comma back here so we can go to the third argument. The third argument is giving us an idea of, okay, all right, so we have an initial value to start the series with, the value to start with, number 6 in this case. What do I try to do in every step? That's what it's doing. So in each step, we could, for example, increase the series by 1. So the first step would be 6, and then we get to 7, 8, 9. To do that, we can start our next argument, and we could say each of the values that it creates should be the value that existed plus 1. And then we could say here the value to create next in each step. I'm just going to show you what the result of this is. So we could click OK. And at this point, we simply see the number 6. Now, how should you imagine this? So it's what first of all is happening is the initial value is 6. Now, before List.Generate returns us any value, it will try to evaluate if this value is fits within the condition in the second argument. So if we would make this, for example, 5, this would mean, let's see. I'm giving the wrong example. Let's leave this 6, but we change the condition to 5. So what it's doing here is in the second argument, before it returns anything, it checks whether the initial value is true to the condition, so lower than 5. And in this case, our initial value is already bigger, so it doesn't return us anything. Now we could turn it around again and say, like, hey, we want to return everything smaller or equal to 6. And in this case, 6 is smaller or equal to 6, so it returns that. Now, here's what's fun. To continue, after it returns 6, Power Query will go to the third argument, and it will say, I'm going to try to apply this function to create a new value. So number 6 will be taken, the underscore suggests that, and 1 will be added. But before returning that value, it again checks, does this satisfy the condition, yes or no? And 6 plus 1 is 7, which is not lower or equal to 6. But if we would change this, for example, to number 10, we're now going to get a series that starts at 6, and then it keeps generating new values and adds a single value to it until the condition is not met. And that's why we see this list from 6 to 10. In this way, you can very easily create a list from 1 to 10, for example. There we go. So that's in its very basic is, first I showed you how you can return a single value, and this now shows how you can create a consecutive list of numbers. We can also reverse this. So now we showed a value that started at 1 and went to 10, but you could also show a series that starts at 10 and goes to 1. So we could, for example, say like our first value is 10, and all the values we return need to be bigger or equal to 0, or to 1, we just said. Now in each value, we want to say like, okay, we take the value we already have, and we subtract 1 out of that. And now we get a list that's reversed. So it starts at 10, and it ends at number 1. I hope that makes a little bit of sense. So this is logic in its most basic form. Let's look at a bit more of the more advanced examples. So we could also apply logic to this that is not a consecutive list. So let's say we're still starting at a value like the value number 1. And in this case, we only want it returned as long as the value is smaller or equal to 1,000. Now, instead of just returning a 1, increase each of the steps by 1, we could also add multiple steps. We could say plus 5. So each of our steps starts at 1, and for every increase, for each increment, it increments with a step of 5 until it gets to 1,000 right there. So that's another thing you could do. Instead of just adding a number, you could also multiply things. So we could also multiply the number by 2. As you can see, we start with the number 1. Then number 1 is multiplied by 2. Number 2 is multiplied by 2 again. 4, 8, 16, until you get to 512. Because then once you multiply 512 by 2, it will not satisfy our condition anymore. That's another example. You could also multiply the value that you provide by itself. So I could write, each of the list values I create, I want to multiply by itself. Now this is going to turn into a very big number very quickly. So let's increase this. And 1 times 1 is always 1, so this is going to be an endless loop almost. So let's start the value by starting with 2. Let's see what happens. As you can see, this increases quickly. So the initial value is 2. 2 times 2 is 4. 4 times 4 is 16. 16 times 16 is 256. And before you know it, we get to very big numbers. But this just shows that you can apply logic to this in a way that you find fitting. Okay. Let's find some more interesting examples, because all we've done so far is provide the list with a single number and apply an operation on this number. What we could also do is provide the list with multiple values. And we can do that by trying to duplicate the Fibonacci sequence. Let's have a look at how we can do that. So we're going to adjust this. And at the moment you want to provide multiple variables. The easiest way to do that is by creating a record. And a record you can create by opening a square bracket. Then I'm going to create a value called x. X is 0. You write a comma for the second value. Y is 1. Now before we continue with this, let me just show you if I just copied this. And I put this in the next step. Then this shows what a record looks like. So our record here, it shows that x is 0 and y is 1. And this is what it returns. So even without the list generate, you can work with a record. Now let's go back. Okay. So before we actually did a check on whether the value that we had in the list would satisfy a condition. In this case, for the Fibonacci sequence, we're going to check if x plus y will equal a certain amount. So we could, for example, write x plus y is lower or equal to 100. And I capitalize something here, which I should not have. All right. Now the Fibonacci sequence, what is actually a Fibonacci sequence? A Fibonacci sequence takes a value, the 0 and the 1 to start with, and the list continues by adding each of those values together. So the first value would be 0 plus 1 is 1. On the next step, x will turn into 1, and y will turn into 1 as well. It will remain 1. And then in the next step, it will be 1 plus 1 is 2. And in the next step, it will be 1 plus 2 is 3. So the sequence for Fibonacci always adds up the last two numbers in the list, adds them together, and then again adds up the last two values in the list. Now what does this look like? So for our logic, we could open a bracket and write that y equals x plus y. And now I'm going to add some more. I'm going to keep this in the screen here, and we're going to write that x equals a y. And we take away the rest. Now I'm going to format this a little bit more clearly, so we have enough space to explain all of this. There we go. And then perhaps it's easiest for our readers to get here. Great. So everything that I'm writing here is still the third argument. So what have we done here? So for each of the next steps, what I've provided here is I'm telling the function that the y that we started with, we said that in the first value, the initial value, y is equal to 1. In each of the steps, I'm telling Power Query, I want you to change y to the sum of x and y. So in step 1, that would mean that that x is 0 and y is 1. In step 2, y is 1, x is 1. And in step 3, y is 2, x is 1. Step 4, y is 3, x is 2. So it keeps adding like that. So what it's basically saying, in each of the steps, y will equal x plus y from the values that we just provided, and we will change x in the value for y. Now we haven't spoken about the last argument yet. There is a fourth argument which is called the selector. And the selector allows you to perform an operation on the list that is created so far. So in our case, we are interested in adding up both the values for x and y. And now I provided this with a capital letter and it's capital sensitive. So there we go. So we have x and y. And we have an unknown identifier somewhere. Okay, x and y. So the mistake I'm making here is we still need to write each. And for each value, we do each x and y. Now have a quick look at this list. So in our list, our first value is x 0 plus y is 1. So 0 plus 1 is 1. In the next step, x changes to 1 and y remains 1. So 1 plus 1 is 2. Since we now have the two values, we have 1 and 2 as a single value, then 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 5 is 8. 8 plus 5 is 13, and the list goes on. So that's how you can create a Fibonacci sequence. So in essence, what it showed, you can create a record, and you can reference the values, the columns within that record by referencing them the way I just showed here. We could have another example like this to make you understand what's happening. One example is we could try to perform a function on each of the values. So let's say we start with this base. We want to start with two variables. The first variable is x is 1. The second one is y is 1. Now, we want to make an increasing series of x, and we want x to always be smaller or equal to 10, because we want a list of 10 values. Now, what we're going to do is we're going to provide that x is always x plus 1. So in each step, in the first step we start with x is 1, and in each of the steps I want x to increase by 1. So in step 2, that will be 2, step 3, it will be 3, etc. Now, to make this easy, I think I would like this here, and I'm just going to paste this to the bottom, so it's a bit clearer what the order is. There we go. So in each of the steps, x will increase, but for y, I would like to return the factorial. And Power Query has a function called number.factorial, and we want to apply that to each of the steps. So what we can do is we could provide number factorial, and instead of providing it to a hard-coded number, I just want that sequence of x, I want it to be returned here. So in each of the steps, it will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and that will be provided in each step to y as well. Now, in the beginning, we're going to use the last argument, the selector. Selector allows you to select/transform the sequence so far. That's great. And I just missed a bracket here. There we go. Now, to make things easy, let's first have a look at what we've done so far. So I've started by having a record that says x is 1. We will only return x for as long as x is smaller or equal to 10. And in each of the steps, x will increase by 1. And since I will return x, we can ignore y for now. So x is nicely showing 1 to 10. Now for each of these steps, you could also apply the number.factorial. So if instead I want to return y, I could change this. And you're going to find that the list here returns the factorial number. Now, this would have been the same as if I had an x here, and I transferred this list to a table, and I would create a custom column. Then I could apply number.factorial and apply it to column number 1. And by applying it to each of those steps, you see that these values are identical to what it would have been if I showed y right there. So what I'm showing you here now is List.Generate can work with multiple variables. You can use one variable to create a list and the other variable to apply a function to the already generated list. And then you just return a single column. That's the factorials for now. Now, so far we have only looked at number sequences, but you can also return text values. So if you want to return the month names in a year, let's see if we can make an example for that as well. So our List.Generate, we can use this as a basis, but instead of having a y as a number, I want to show the date. So I could write 2021 1/1. So this will return the 1st of January of 2021. Now, what I would like to do is create a sequence of x of 12 values. So each of the months is going to have a number here, 1 to 12. Now, in every step that the function takes, x will increase by 1. And right here, we can provide a date function. So I wanna basically start out with the first date function here, and with each of the steps we take, we would like that date to go to the next month so that we can return it. So we could, for example, use the function called date.addMonths. Then we start with the date that we have as a first value at the top here. So in each of the steps, it's going to start with this date value, and then when possible, increase that by 1 month. Here we go. And then we can return y to see what happens. So now at least you can find that there are 12 different dates, and each of the dates is the start of the month. Now let me show you a bit of a trick here, because one of the things that might confuse you is that on this list, perhaps you're thinking now, if I want to return a value for a month, I could provide date.month name. Now ask yourself, are you expecting this to work? Because if you're like me, you might imagine that this is going to work. But instead, what you see is the first value is okay, because it's the initial value. And because we applied this function here, the second value will return a text value. And trying to apply the date.add months for the next step will result in an error because there's no date value anymore and there's only text. So this is a perfect example of why the selector can be so beneficial. So what can we do instead? Now, if the third argument returns our list like this, then in our selector, we could actually write date.monthName, which will use all of the dates that we already generated, but now transforms them into a month name, just like that. And you can even change this to add some text. So you could write something like, I love the month, space, write an ampersand, and all of a sudden you've returned the whole list of text values and combined it with the series that we just had. Now we just did this here with the month names, but we could also do that with the days of the week. So if this is the start, well, the days of the weeks are 7 days. So you could change this to create a series of 7 days. So X is perfectly fine. And instead of adding months, we're going to start with the initial date now. All right, date at days. We're going to increase it by a day. I love the day. And we could write here date dot day name, day of the week name. And by changing this, we are very easily able to create a list of values. We can even create sentences. And this makes it super flexible. We just created a whole bunch of values by combining text. We used a series where we applied a function on and we return text values. So you can see how versatile the List.Generate function is. And if this is providing you value, it would be great if you press that like button. Continuing from here, later I'm going to release another post that will show how you can use List.Generate to even empty an API. And you can use List.Generate to return values, which could be a table function, an object, it could be a list. We've shown in these examples that it could be text or numbers. As long as you have the creativity, you can adjust it to the way you want to have it. Now, I can imagine this still gets you confused in some ways. Let me know in the comments if this was any clear and what else you would like explained. I would love to help you out there. But that's all the examples I wanted to show for now. I also have a written blog post, so look in the comments if you want to see that. And with that, this is the end, and I'll see you in the next post. See you.